Alright, so this video is going to be part 2 of our absolute / conditional convergence practice. Okay, so we want to, again, prove if this series is absolutely convergent or conditionally convergent. And our series is the sum from n equals 1 to infinity of sine of n over 2 to the n. Okay, so this sine to the n, or sine of n, this is going to kind of throw us off here because now we're going to get terms that are positive and negative, and it's not any like pattern. Okay, it's happening irregularly. Okay, if you started listing out terms here, okay, the denominator, well, that's always going to be positive, but you see this numerator here, you get sine of 1, sine of 2, sine of 3, and well, sine of 1, that's going to be positive, sine of 2, and we're talking about radians here, okay, sine of 2, well, that is going to be positive because sine is positive in the second quadrant. And you also have sine of 3, which will be positive. However, sine of 4, that will be negative. Sine of 5, that will be negative. And so on and so forth. There's really no pattern here. Okay? So what that means is that we're not going to be able to prove convergence or divergence using any of the tests that we know right now. Okay? So what we're going to have to do is try to prove that this is convergent by proving that it is absolutely convergent. How we do that is by taking a absolute value of the series. So we have the sum from n equals 1 to infinity of the absolute value of sine of n over 2 to the n. Now this absolute value is only going to really apply to that sine of n because 2 to the n power, well, that's always going to be positive, okay? We're only plugging in a positive n, but that doesn't really matter because 2 to any exponent is going to be a positive number, okay? Now, sine of n. Well, that's now, since it's the absolute value of sine of n, that's going to range from 0 to 1, okay? So a good comparison here would probably be 1 over 2 to the n. Okay, because you know that if I draw them both out here, that this, okay, this absolute value of sine of n over 2 to the n is always going to be less than or equal to 1 over 2 to the n. All right, so that means that we can use the comparison test here, okay, and we need to figure out whether this series is going to converge or diverge. Okay, this series is going to be, let's write it right here. Okay, the sum from n equals 1 to infinity of 1 over 2 to the n. Now this looks a lot like this looks like we could make it a geometric series, so let's try that. We do the sum from n equals 1 to infinity of, well, using what we know about our exponent properties, we can break this up into a 1/2 times a 1 over 2 to the n minus 1. Okay? When you multiply this through, you get a 2 to the first power times 2 to the n minus 1. You add the exponents, you get 2 to the n. Okay? Now, we can say that this is 1 to the n minus 1. Okay? Why can we all of a sudden put a power in front of 1? Well, 1 to any power is going to be 1, right? So we can just put this n minus 1 on the outside, and there you go. We have our geometric series. Now our common ratio, right here, this 1/2, that's important. Since this 1/2 is greater than -1 and less than 1, we know that this series right here, this series converges, okay? So this converges, which means that this series converges by comparison test. Okay? Which, again, means that this series is absolutely convergent. And, of course, we've already answered the question, but one thing to note is that since this is absolutely convergent, it's also convergent, okay? So, it's also convergent. Okay, that's something that we learned when I introduced absolute and conditional convergence. Okay, if something is absolutely convergent, then it converges. Okay, so that's going to do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences and series, the explanation video for absolute and conditional convergence, and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.